Good morning or afternoon, everyone. I'm back, and if you're watching this, we are asynchronous today, and so we want to make a video guide to help you through the classwork for day 2 on Thursday. Hope you're all doing well. Hope you don't have a lot of shoveling to do. So let's get moving on. Now, for the first 6 problems, what you had to do was you had to give the information necessary to prove the triangle congruence through the methods that they state. Okay, there we go. So for problem 1, we wanted to prove these two triangles congruent by HL. Now remember, in order to prove triangles congruent with HL, we have 3 conditions we have to meet. First, we need them to be right triangles. Secondly, we need a corresponding leg to be congruent. And third, we know that the hypotenuses have to be congruent. In this triangle, we have angles EDG and angle blue FDG are our right angles. Therefore, by the definition of right triangles, triangles EDG and triangle FDG are both right triangles. The two triangles also share a side, DG, and that is a corresponding congruent leg by the reflexive property. And remember, always mark your diagrams so you can see that you have the correct correspondences. And then thirdly, we are looking to make sure that the triangles have congruent hypotenuses, which were not given in this information. So in order to prove that these two triangles are congruent, we need to know that segment EG, I'm going to highlight that in really dark blue. We need to prove that segment EG is congruent to segment FG, or that segment GE is congruent to GF, whichever way you wrote it. I'll draw this one up in yellow. And once we have that, we can prove that the two triangles are congruent by HL. All right, so for problem 2, we want to show that triangle AFB is congruent to triangle DCB by angle side angle. So first we want to remember that in order to show these triangles congruent by ASA, we're going to need an angle, the included side, and then another angle. And what we're going to do is we're going to look at the right angles first. So we have angle AFB here. It's congruent to angle DCB because both are right angles. So you want to make sure you mark them with an arc. Remember, it's important to mark your diagrams so you can see what you need, especially in problems like this. And since right angles are always congruent to each other, that's our first correspondence. This gives us our first A. Then we also have angle ABF is congruent to angle DBC by vertical angles. And I'm going to mark this with 2 arcs here in the middle. So these 2 angles are congruent. This gives us our second angle. Now we need the included side for these pair of angles. So remember, the included side is the line segment that's formed by the angle at each end of it. And in this case, we are looking at the sides FB and CB respectively, or BF and BC respectively. And we're going to mark that. I'll just mark with 2 tick marks because I just did that for 1. So once we have that, we can then prove the triangles congruent by ASA. And that's the last bit of information we need for that problem. Now for problem 3, we're given these 2 triangles over here, triangle NPQ and triangle VXW, and we want to prove them congruent by side angle side. Very similar to the last problem, we want to make sure that our angle is the included angle. Otherwise, we're either going to have a different congruence or we're not going to be able to prove them congruent at all because we may have SSA. To start with, we have segment WX is congruent to segment QP, and that's already marked by one tick mark. And then we have angle WXV is congruent to angle QPN because both are right angles and all right angles are congruent. So I'm just going to mark that with a single arc. Now, it's important to note that we are looking for the angles here, the right angles, to be the included angles. So we couldn't do the hypotenuses because that would then give us angle side side and angle side side. And we know that that is not a congruent statement for geometry. So for our angle to be the included angle, we need that PN is congruent to angle or segment XV. I'll just mark them with two tick marks. So then that gives us our side. I'll highlight it up here. Our angle, and then our side. So PN congruent to XV or NP congruent to VX, whichever way you write it. Okay, now problem 4 is a little bit trickier. Not much, just a little bit. When I looked at this, I had to think about it a little bit more than the other ones. For this one, we want to show that the triangles are congruent by angle, angle, side. And when I was doing this and checking, I had to think backwards a little bit and look for our side congruence first. Then I knew which angles I'd be looking for. So we see that JL here is congruent to itself by the reflexive property. And that gives us our side congruence. Next, we also see that angle JLM here is congruent to angle JLK because they're both right angles and all right angles are congruent. So we mark that with one arc on each one. And that gives us our angle. Now, it's important to note that this is our second angle because we can't have angle LJM is congruent to angle LJK because that would then give us angle side angle. And we want to show it by angle, angle, side, meaning the last angles that we need are angle M and angle K to be congruent. Because when you read this like that, you will get angle, angle, side, and angle, angle, side. And that is it for this one. So for problem 5, we're given triangle STV and triangle YXZ, and we want to prove them congruent by side, angle, side. So for our first side, we have TV is congruent to side XZ. I'm highlighting them in brown, orange. I'm not very good with colors. And we want to mark that with one tick mark. I should actually mark the S. It's going to be one of our S's here. I'll do that one. For our angle, we have angle STV is congruent to angle YXZ. And we'll mark that with one arc. And that will be our angle. And then remember, in order to prove congruence by SAS, this must be our included side. So if we were to say segment SV is congruent to segment ZY, we would have angle, side, side, and we cannot do that in geometry. No matter how much we want to, we're not allowed to do it. Therefore, this right angle here is just misleading information. It's extra information. So the segment that we need congruent here in order to show the triangles are congruent by SAS is segment TS congruent to segment XY. Mark that with two tick marks. I'm going to highlight it. Then when we go through it, we have side, angle, side. And for problem 6, our last problem of these types before we get to the proofs, everybody's favorite, we have to prove these two triangles, triangle BCA congruent to triangle DFA by HL. Now remember, we have 3 conditions that are necessary to prove triangles are congruent by HL. So we see that angle B and angle D are right angles. Therefore, we have our 2 right triangles here. And I'm just going to highlight the entire triangle. I don't know if highlighting the whole triangle is correct or not, but we will work with it. And we see that the hypotenuses of these triangles are congruent with CA, congruent to AF, because they are marked with a single tick mark. So what we want to do is we want to make sure that we show that. And I'm just going to draw a green line through it to show that the hypotenuses are congruent. Now to prove the congruence of the 2 triangles, we need one of the corresponding legs to be congruent. It can either be leg BC congruent to DF, or CB congruent to FD, or we can do segment BA is congruent to DA, or AB congruent to AD, whichever way you write that. Both of these are correct because then we have our corresponding side, or our corresponding leg congruent to show the triangle congruent. So I'm just going to mark them with tick marks. So we have the right triangles, we have the hypotenuse congruent, and then either BC congruent to DF or segment BA congruent to DA. Either way is correct. Okay, so for problem 7, we have proofs. And if you'll notice on your paper, we are only given the first box in both of these proofs. And we are given in here if segment HV is perpendicular to segment GT and segment GH is congruent to segment TV, and I is the midpoint of HV, we want to prove that triangle IGH, I'll highlight that in yellow, IGH is congruent to triangle ITV, and that will be in green. Now we have 5 different tools to show that these triangles are congruent. And what we're going to need to do is we're either going to need to show that 2 sides and an angle are congruent, or that we have right triangles, congruent hypotenuses, and a congruent leg. What we're going to do is we're going to work from beginning to end. We're going to go with segment HV perpendicular to segment GT, and that reason is given. We then know that GIH is a right angle and TIV is a right angle. I'm going to draw a right angle in there as best as I can. Look at that. I should have been an artist. And that's by the definition of perpendicular lines. We went over it in class that whenever you have a single right angle, then all the angles in that segment are, in that quadrant, are right angles as well. And now because we have right angles, remember when we have right angles, we're generally going to start looking for hypotenuse leg first. Then triangle IGH and triangle ITV are right triangles. That is our first shape. That is our first bit working towards the hypotenuse leg. So now we're going on, okay, we're really looking for this. And by definition of right triangles, that's just what it states. If there's a right angle in the triangle, then the triangles are called right triangles. We've done all that we can with the perpendicular segments for now. Now we're going to go to the second segment of GH, congruent to segment TV. Make sure you mark your diagram. GH congruent to segment TV. And the reason for that is given. Nice easy one. We figured we'd give that to you. But we actually had to because that's important, because now we have the hypotenuse of triangle IGH and the hypotenuse of triangle ITV are congruent to one another. Meaning now, by hypotenuse leg, we just need to show one of the legs are congruent to the other. And what we're going to do is we're going to use this third bit of information here, that I is the midpoint of segment HV. So we know that this is by given information. However, when you have a midpoint, you know that you can write an equivalent statement, that segment IH is congruent to segment IV, and that is by the midpoint theorem. We'll make sure that we have our diagram marked. And right now we don't have any way to write, like the SAS we can write in the margins here, but we don't have that for the hypotenuse leg, so I would recommend going in order that you have the right triangle, the hypotenuse, and then the leg congruence. And what we have here is triangle IGH is congruent to triangle ITV by HL, and that is in statement 3, 4, and 6. Okay, for problem 8, we are given that segment BS is congruent to segment YS, that segment OS is perpendicular to segment BY, and we want to prove that segment or angle B is congruent to angle Y. I'm going to highlight the angles that we're trying to prove congruent here. We'll prove that angle B is congruent to angle Y. We'll do Y in blue. And we see here that we have a right angle. So as we've been doing, we're going to be looking for hypotenuse leg in this one. But we're immediately given that BS is congruent to segment YS. And that's in our given information. So we want to mark that with a single tick mark. And I'm going to draw these segments in blue here. I hope that's not too confusing, but it's what I'm going with. And then we have segment OS is perpendicular to segment BY. Now think about, what do you know about when two lines are perpendicular? Because we can't do anything with BS and YS at the moment, but we can do something when we know that two lines are perpendicular. We know that OSB is going to be congruent to OSY because perpendicular lines always form adjacent congruent right angles. What we're going to do is we're going to mark that with, I want to mark it in that blue, with an arc at each one. Now, if we're going for hypotenuse leg, we would state that these are right triangles, and that is true. However, we don't have any kind of information to show that segment OB is congruent to segment OY. Because we don't know anything about the hypotenuse of these triangles, we won't be able to use HL. But that's the beauty of having 5 different tools, is when one doesn't work, we can generally fall back on one of the other ones. In this case, we see that the two triangles share a side. And anytime two triangles share a side, we know that the side is congruent to itself. In this case, OS is congruent to OS by the reflexive property. And I should be marking these as I write them, because now that we know we're not using HL, we want to show that we have BS to YS, SS, and I want to do this color for the A. And right here, if we go down the triangle, we have SAS, meaning that we have triangle BOS is congruent to triangle YOS. And because of the way we have side, angle, side in statements 1, 3, and 4. Make sure you write that there in your reasons. It's important to check your work and be able to see that you have the congruent statements. And if you hand this in on a test, a quiz, a homework, we're going to be able to keep track and help you to figure out where we can improve on this. But that's not what we're trying to prove in this one. We are trying to prove that angle B is congruent to angle Y. Because we've proved triangle congruence, we know that angle B is congruent to angle Y by CPCTC. And that's all for this problem. We have one more coming up. All right, for problem 9, we have this. We're given a lot of information, and we want to prove that segment GH is congruent to segment KJ. I'm going to do that in blue. And if you look at this, it might help you if you draw the two triangles separately. I will try to do that. I'm not very good at drawing with a mouse. I'm not even very good at drawing with a pen. I'll do the other triangle in green, so hopefully we can see what's going on here. And this triangle is going to be much smaller because I draw too big and have run out of room already. And that's a right angle here. And that's a right angle there. Okay, well, as usual, we're going to start with the given information. We have GH is perpendicular to HJ, and that KJ is perpendicular to HJ. Then we know that GHJ and KJH are right angles. And we know that's because perpendicular lines intersect to form right angles. So what we see here is now that we know we have perpendicular lines and we have right angles, we're going to try to look for HL. And in order to start with HL, we're going to go with right angles and then stating immediately after that GHJ and KJH are right triangles. That is by the definition of right triangles. Now, we know that for HL, we need the triangles to be right triangles. We need the one corresponding leg to be congruent on each triangle. And we know we need the hypotenuses to be congruent on each triangle. So for the second part of our given, we're given that GJ is congruent to KH. What I'm going to do is I'm going to mark that in a bright red. GJ is congruent to KH, meaning now we have the hypotenuse congruent. And that is given. And now we know that HJ is congruent to HJ. This is a little bit harder to see in the diagrams that I drew. But if you look right here, you'll see that HJ is going to be congruent to itself. These triangles do share a side, even though it's not the side that we're used to seeing. We're used to seeing the one in the middle. But a shared side is still going to be congruent to itself by the reflexive property. I'm going to mark that in an X in yellow. And I will draw it over here with the tick marks. I guess I better mark the original triangle too, huh? Now we have our right triangles, we have our corresponding leg congruent, and we have our hypotenuse congruent, meaning that we can state that triangle GHJ is congruent to triangle KJH by a hypotenuse leg in statements 3, 4, and 5. But that's not quite what we're trying to prove. We are trying to prove that GH is congruent to segment KJ. And we know that because we've proven triangle congruence, we have also proven that corresponding parts of triangles are congruent. Therefore, GH is congruent to KJ by CPCTC. And that is the last problem for today's classwork. Hopefully, you're having a wonderful day in the snow, and hopefully, we will see you tomorrow. No guarantees. A wonderful day, everyone.